All right, so I had a request to kind of go over the quadratic inequalities. Like, okay, I understand factoring, but I'm not really sure what's happening after that. So, in Algebra 2, in Unit 1, which I understand for some of you was a long time ago, we did this through graphing. So you're like, I've never seen this before. Well, that's because we did it a different way. So I'm going to kind of combine the two for you. What your homework's wanting you to do. So I'm given something like this. And it says, hey, factor it. Okay. So I factor. If you don't know how to factor, you need to watch that video before, because this is assuming that you get factoring. So make sure to watch the factoring video before this one if you don't remember how to factor. Okay. So then you factor. This tells you that the zeros, okay, so what I could plug in to actually get 0 would be -5 and -3. Recall when A is 1, it's always just the opposite of each of them. If you are still struggling, remember you can set each of them equal to 0 and solve. So in this case, that's how I got -5 and 3. So here's the idea. I know that these are points. Think about it on a graph. And I think this is the disconnect that's happening because your work on MyLabs is not using an XY graph. So when I am on an XY graph, that means that my 2, 3, 4, 5, my x-intercepts are at -5 and -3. Also recall with the quadratic function, since it's positive, I know that it's pointing up. I don't know where the vertex is, but I don't care because this is the part I care about, okay? So here's what I know. I know that everything above the x-axis is positive. Okay? I know that everything below the x-axis is negative. So positive, negative. How does that help me? Well, that helps me because I then see my original equation says this function greater than 0. Well, greater than 0 is positive. So these are the intervals here and here where all the values are positive because it's greater than, okay? And so writing that in interval notation, I would have from -infinity up until that point, so -5, joined with the next piece, which picks up at -3, infinity. Okay, so this would be the answer for the intersection. Now, some of your problems, I was working through your problems before I started this because I wanted to make sure that I understood all of it and what's being asked of you. So, one of them says if, let's just use those same points. -3 and -5 were my, how do they word this? The solutions that represent the boundary points. What are all the intervals? So the intervals are everything around it. So you have an interval here. You have an interval, whoops, not there, in the middle. And then you have an interval at the end. So there's 3 intervals, and that, like this one's a multiple, I'm looking at number 2 on your homework. It's a multiple choice question. And as far as the bracket versus parenthesis goes, well, I know it's going to be a parenthesis if there's no equal to. So just like your previous tests, less than and greater than are just parentheses, whereas like equal to would be your brackets. So that hasn't changed. Math doesn't change. That's in fact why my nerdy self finds it fun, because I'm a rule follower. There are rules. They don't change. And so I can figure things out because I know what the rules are. Sometimes that helps people realize like, oh, it's not as bad as it seems. So for this one, like, would be negative infinity up until -5. There's an interval here, -5 to -3. And then there's an interval here all the way to infinity. If I were to test a point, so like the way that your homework's kind of wanting you to think about it is testing points. I pick a point in the yellow, so something like -10. Does it have to be -10? Absolutely not, because there's a lot more numbers. It could even be a decimal or fraction, although why you would do that to yourself, I do not know. Something in between here. I'm probably going to choose the most common there, -4, because everything else is going to be fractions or decimals, which are the same thing. And then here, maybe I choose 0 because that's typically pretty easy. If I were to sub those into the original equation, so either of those top two there, it could be the very top one or the second one, because remember, they're the same. If I plug in -10, I'm going to get a positive number. I already know that because I know from the graph that it's positive at -10. Okay. If I plug in -4, I know that I'm going to get a negative number because -4 is in the negative zone of the graph. And same with the end here is positive. Okay. So just FYI, help you out a little bit. Let me go through here. That should help you with negatives and positives. There are a couple of problems where I actually had to go to view an example just to see how they wrote it. So for instance, knowing that the solution, they want the U in between. Okay. And then let's see. These look pretty repetitive, the same thing over and over. So yeah, hopefully using a graph will help you out. It looks like all of your x squareds are positive, meaning that like all of your parabolas are pointing up. It's just where they're at on the x-axis is going to change. So therefore, if you get one that's greater than, it's going to be in 2 pieces. Whereas if it's less than, it's just going to be that one interval in between. So that should actually help make your work easier. The only other thing that I would say, and this is more along the lines of factoring, is if you have something that is, so one of your homework problems, I'm going to scroll down. It's 2x squared minus 7x is less than -5. The first thing I would do is set that equal to 0. That's totally wrong. Sorry. Too early in the morning. All right, so something like this. Use any of those methods that we discussed before. So what multiplies to get positive 10, because 2 times 5 is 10, but adds to get -7, that's going to be -2 and -5. So I'm using splitting the middle term right here. So when that factors, I get 2x minus 5 and x minus 1. Again, if this is not your factoring style, pause the video, go back and do your factoring style, and make sure that you end up with these same factors, okay? All right. So now when I talk about my intervals, think about setting each one equal to 0. This one, I would have to add 5 and then divide. So x is actually 5/2. And then, of course, this one is much easier. X is 1. So my 2 spots here are 5/2 and 1. I haven't tested to see if decimals work, or hold on. Using integers or fractions. So it does not want decimals. So 5/2 would be it. 5/2 is 2.5, so that's bigger than 1. So when I'm thinking about a number line here, it's going to be 5/2 here, 1 here. This is a case where it's less than 0, so it's the interval in between. So my answer would be 1 to 5/2 is the right answer. This is actually one of those that wants all 3 intervals, and you state whether it's positive or negative. So negative infinity to 1, and then 5/2 to infinity is the other one. And then this one's positive, negative, positive. So this is your answer. So that's how you do when A is not 1, meaning you have a number other than just X out front. Just expect fractions. I think that this covers pretty much everything in a brief-ish type video. If you need more help, let me know. I did extend the deadline until tonight. I don't know how that works in terms of... I hope that it works okay. If it doesn't work okay on my Labs Plus side, just know that it's fine. I will fix it towards Infinite Campus, and Infinite Campus is really what you should be paying attention to anyway. Okay? And I think that's it.